Okay, we're going to look at the basics of an exponential graph, just the basics, and some things that we'll need to know going forward. Okay, so an exponential, this camera, board's a little dirty there, but we'll be able to see it. Exponential graph is a graph whose equation will take this form. Basically, I have a variable in the exponent. There's two big things I want you to know. First of all, occasionally you'll see a number up here. I'll go ahead and put a -1 just to include it. It's not as important as this +4 for just knowing the basics. Now the -1 does do something. It has a slight shift to the right, but the +4 is a bigger determining factor on where the graph is. And of course you could graph it on Desmos, but we're trying to get the basics without the aid of a graphing utility. So what I want you to know is that this number is a vertical shift. You're adding on the outside, and it creates what we call a horizontal asymptote. It's a funny word. Here's how you spell it. Okay, an asymptote is a line that a graph approaches more and more closely, and often is a line that is never crossed. So for an exponential, the asymptote will be where this big number is here. The other big thing I want you to know is which way it's going, and that's determined by the base. Okay? Briefly, when we look at the base, for an exponential, we have two possibilities. You can either be between 0 and 1, in this area, or you can be bigger than 1. Okay? Three things you cannot be for the base of an exponential. You cannot be negative, so we don't even consider that part of the number line. You cannot be 0, you cannot be 1. And there's reasons for that we'll discuss, but if you're in this area, it's called a decay. And that's not the case here because this is bigger than 1. If you're bigger than 1, it's called a growth, which is going to be this case. Now if I'm just freehanding this graph, I know growth is going to look like this. I'm going to graph it and then we'll talk about it. So it's very close to the asymptote, very close, and it starts to bend like this. Okay, so it's quite flat on one side and quite steep on the other. This one had a small influence on the graph. It actually did push it a bit to the right, but you'll need a little experience with the exponential graph to know where to put it approximately if you're approximating the graph. So again, this number determines the asymptote, and the 2 determines that it's a growth here. And growth graphs look like this. I'm going to show you a decay graph with my next example. Okay. So the analysis of this graph, we're going to talk about the domain and range here. You've heard those words before. Domain are all possible x's, range all possible y's. From a graphical standpoint, what are all the possible x's? Well, the x-axis we know is the horizontal axis, and it's going to go in a sideways or horizontal fashion. So we're going to go forever to the left, and as you'll notice, it is still tending to the right, though it's not very quickly going to the right. So our domain here, we're going to say, is all real numbers. All real numbers, which is quite a common domain. You see that a lot. It just goes everywhere. It doesn't have a limit or a boundary. The range is all possible y values. We know y is the vertical axis. Now the range is not all real numbers because it only goes down to the asymptote. It never goes below it. And it goes forever up. All right, in Algebra 1 we're going to use inequality notation. So we say our range here are all y values that are bigger than 4 in this case. Okay? It can't be 4, nor can it be anything less than 4, as you can tell with the graph. What that means is, for the function, is it's impossible to generate a y here that's less than 4. This part cannot be 0 or negative. Therefore, the whole thing cannot be below 4. Okay, so just some ideas about one of these graphs. We'll look at a second example. I want to highlight some of the same ideas, and we're going to look at the decay instead. So sometimes you'll see a number in front. Again, I'm going to put a small number here. So we have this graph. The most important numbers here in determining an approximate shape of this graph is the 3 and the 1/2. Okay, we don't care so much about this 2. We don't care so much about this 3. They each have an influence on the graph, but it's not as important as the influence of the 3 or the 1/2. When I graph these by hand, I always look at this first. Okay, so we're going to go down 3, and remember the word there is asymptote. Okay, so I have a horizontal asymptote there. This line will not be crossed. Now, for the base, if you remember the order of operations, the 1/2 must be carried to its exponent before the 3 is considered. Therefore, you cannot multiply 3 and 1/2 here. We don't know the value of x. It's given the ability to vary. So this 3 and 1/2 cannot be multiplied. The base is only the 1/2. It has nothing to do with that 3 at all. So the base is less than 1. Remember the graphic from before. If it's between 0 and 1, it's a decay. And so this graph is going to look like this. It's going to be steep on the left-hand side instead. And that's going to get very, very close to the asymptote. And actually get closer and closer, but never quite at any point cross that. The 2 did bump it slightly to the left. Again, we're not going to worry too much about that when we're freehanding. The 3 actually steepened the graph a bit. But the main features is, do you notice the decay? And do you know where that asymptote is? Back to that domain and range. Domain are all possible x values. It goes forever to the left, it goes forever to the right. So we'll say all real numbers, which again is very common. And that will be the domain of every exponential graph. Not every graph there is, but every exponential graph. The range here, it goes down to the number -3, and from there it goes up forever. So I'm going to say y greater than -3. Basically, the asymptote here will show up in the range. And there are some different looks here. It is possible, for example, to flip these upside down and do different things with them. But I just want to show you the basics. Where's the asymptote, growth versus decay, and domain and range for one of these.